Hello, everybody. Hello, everybody. All right. Yeah, my name is, wow. Do you guys hear me too strongly? It's okay? I hear myself very loud, but anyway, my name is up there. I'm Luca Bolognese. I'm a lead program manager for the Link project and the C# team. So that's what I do in my daily job. How many of you have been in my presentation yesterday on Link? Okay, plenty. I have to repeat some of that material for those of you who weren't there. My presentation yesterday was 2 slides and then kind of 55 minutes of demo. This one is very different. I have 3 slides. So, but it works the same way. So, all right. So many of us, when we go and we use data, we have this feeling. We feel like we are not expressing what we want. We feel like we are just trying to bridge things that are different somehow. It's like you're working and you have that thing in a corner, this dark entity. And the way you communicate with that guy is by sending strings that are SQL statements. And when you do it right, the guy sends you back something, some data that is not your objects. Are not the things that you use. It's not your domain. It sends you back some rectangular data. And then you have to go and pick in this rectangular data and find the information that you really need. And you really do feel like you're a plumber. You're not exercising your creativity. You're not trying to get anything done. You're just trying to bridge those 2 worlds together. And that's not what you want to do with your time. You really want to have fun, to write things that make sense. You just don't want to put those things together. And what we are trying to do with Link to SQL is to make that kind of thing disappear. As so that when you work with your relational data, you feel like you're working with objects. And you have all the tools that can be used there. So that's what we are trying to do, at least. Yeah, this is the same slide as yesterday. I need to kind of talk for 1 second on this one for those of you who weren't in my session yesterday. The way it works, we now have queries inside the programming languages. Once you have queries inside the programming languages, then you can use them to query over objects. Oh, do I have this? Oh yeah, look at that. You can use them to query over objects, over relational data, and over XML. Today we are going to talk about this one. It took me a while to come up. Yeah. All right. How does it work? So you do your query. Now I have to use. Nah, that's fine. You do your query. Your query is in your programming language. It is strongly typed. The compiler tells you if there is anything wrong with your query. As you enumerate on your query, and this is important because the query doesn't get executed when you create it. Right? When you create the query, you're just creating a new query, right? But when you enumerate over the result, when you start the enumeration, that's the point where the query is executed. So you can construct your query in many different steps, and it gets executed at the end when you start enumerating over the results. Okay, so you start enumerating. Link to SQL translates your object query, your query defined in terms of objects, to a SQL query, executes the SQL query. Some rows come back, translate those rows to objects. So now you have your objects in memory, you're all happy. You can manipulate your objects. Then you call one single method. That's the manipulation of your objects. You call one single method called submit changes, and everything is translated back to the database. All the changes that you made to your object model are kind of pushed back to the database. And the only thing that you have to do is to call submit changes. In this presentation, we are going to talk about all of this. And I'm going to tell you exactly how the translation gets done. I'm going to show you the sequel for each one of those steps. So it's an extremely boring presentation. Just want to make sure you're prepared for it. All right, that's the end of my slides. Let's write some code. All right, so this is Visual Studio. I know it looks more like Notepad, but you can bring Visual Studio to this stage. I don't think I told you this yesterday, but essentially you go to Tools option and you uncheck a whole bunch of stuff. I never remember which ones, but and if you do it, then you can never go back. I mean, you can, or you are very careful and you write down. No, I'm kidding. There are settings you can save them, but anyway, you can put Visual Studio in this state if you want to. It's good for demos. All right, first I need those usings, and the one especially I'm looking for is system.data.link. This is where link to SQL lives. Then let's say I want to write an application that works with customers. So I have a class named customer. How do I tell the system where this class is stored in the underlying database? So the way to do that is by going and adding attributes to this class. For example, the table attributes tells the system that the class is stored in the customers table. The column attributes tells the system, well, let me write it down first. Okay. The column attribute tells the system the customer ID is stored in a column called customer ID, and it is a primary key. If it were stored in a column with a different name, you could specify the name there as well. In this case, the name is the same, so you don't need to specify it. Okay, so this is all I need to do to map my class to a relational database. Just that, adding those attributes. If you don't like having attributes in your code, then you can kind of separate them out in an XML file so that your code doesn't contain those mapping directives, but they are external to your code. But this is the simplest possible way to write against a relational database. All right, I want to do something else here. I want to go and create a little class that represents my database. This is the this is the entry point to the framework. When you want to use link to SQL, the most important class you have to learn of is the data context. This is think of it as your database. That's the database. In this case, I'm creating a strongly typed version of it just because I want to get IntelliSense on this method. I want to see all the tables that are in my database when I hit dot, essentially. And so this is a way for me to do it. All right, so now I have a class. I have a strongly typed database. Let me write code against this class. All right, so first thing, I start this class. If you look, there is a constructor that takes a string and send it back to the base class right there. And let's write the simplest possible query. Query equal db.customers. So give me all the data in the customers table. And let's print out the data. First, we'll print it like so. So these are all the customers in the customer table. Allow me to use something slightly more sophisticated here to print out stuff. This object dumper, for those of you who weren't at my presentation yesterday, is just a simple class that iterates over a collection of objects and uses reflection to print out all the properties. So that's, that is slightly more formatted way to print out stuff. All right, so let's start going deeper into this framework. So let's add a log here. What this does, it prints out on the console all the SQL queries that are sent in the database. This presentation is, let me print it out. All right, so these are all the customers, and at the start, you see the query that has been sent to the database. You see that in the select statement, there are just the three columns that I mapped to properties in my class, and then there is nowhere close. There is just a from close because I'm retrieving all the customers, right? There is this context that tells you which SQL provider you're using, and there is this model that has a build number that I couldn't get my developer to take out. But I have no idea what that's for, but anyway. All right, so this is the simplest possible query that you can send. Now let's start to do something more complex and see. This is how the demo works. I'm going to make this query more complex, and more complex, we're going to look at the SQL that is generated. That's the best way, in my opinion, to really understand how this stuff works. So let's do that. Let's do from C in db.customers. Let's start with a simple one, where c.city equal London. And let's select C. And if we execute, this is my result. Notice that now there is a where clause here. The where clause has a parameter, P0, where P0 is defined as London. So all the queries that we send to the database are parameterized. Yeah. They use parameters. And I don't know where you're at. Anyway. Yeah, so where I was, yeah, the parameter. The reason for that is for SQL injection. So if we use parameter, there is no way to get SQL injection there. So that's why we parameterize the whole thing. Something else to notice, and we'll see that as we move ahead with kind of with the demo, is that, well, yeah, let's talk about it. The way that our query engine works, it has a set of steps. So it goes through, it removes all the variables, it works on the where, it works on the select, and it has all those steps in the query pipeline. And what we did, we added a very last step to this pipeline to simplify the query. So if you don't do that, you probably have worked with object relational framework that don't do that. For very simple queries like this one, you end up with a, one page of a query, right? And maybe the database is able to optimize it. So maybe that doesn't matter, but it kind of does. It does for you when you go and debug and you try to understand, what the hell your query is doing, right? So what we did, we'll see it. We tried to keep the query the most similar to the original link query as possible. And we do that in an explicit step at the end of our query pipeline. I don't know if you care about that, but that's how we do it, kind of under the cover. You may wonder, if you are a SQL guy, why we put the from first instead of the select. There are 3 reasons. Wow, now I said 3. I have to come up with 3. There are, there are several reasons for that. Not sure if there are 3, but the most important one is IntelliSense. So if you have the from on top, you are defining your variables so that then when you go to the where clause and you hit dot, we can tell you, all these things because you define your variable on top. If the from is down there, you start writing select, and we don't know what those variables are. So we won't be able to give you IntelliSense. The second reason is that in programming languages, the way that it works is you define your variables up front and then you use them. And SQL is a little weird in that regard of having you to do things the other way. And the third variable is that we looked at SQL programmers. We have these fancy things in Microsoft where you are behind a screen and you look at people writing code. And we looked at SQL programmers, and most often they go and they write the from first. Then they go back and they write the select because they want to define what they are selecting from. And so, the union of those 3 reasons kind of made us choose to put the from on top, even if it might be slightly disconcerting for SQL programmers. So you get used to it after a while. All right, so let's add something here. Let's do an order by. So let's order them by contact name here. And you will see that a simple order by has been added right there. And you can say descending, for example. And now the generated SQL has descending, and you will see that those are in descending order. You see the query being very similar. And we try to keep it similar even when we do more complex query. For example, you say group C by C, yeah. Group C by C.city into G, and let's select new city, key, count G dot count. So if we run this one, you will see those are all the cities with the number of customers for each city. And if you look at the query, this is the way that you would have written this query in SQL. So there is a group on the city, and you are selecting the count up there. Again, this query, to get to this simple form, it went through a very complex form, and then at the end gets simplified back to something similar to what you would have written most of the time when we can do it. All right, so we exhausted what we can do with this simple object model, so let's create a complex one. So this business of adding attributes to your object model works, and to be honest with you, I do it all the time when I write a simple application. It's simple, you just add an attribute and everything works. But if you have a real application with maybe hundreds of tables or so, you don't want to go by hand and write all those classes, add all these attributes. So there is a better way to do that. Let's remove this thing, and let me remove my old code. And let's say that I have a database. I have a database there. I want to write link to SQL queries. So let me go and add a new item, and let's pick a link to SQL class. Let's call it Northwind. I can now go and drag and drop tables, for example, customer and orders. If I drag and drop them, see that the tool looked at the foreign keys and primary key and automatically inferred that there is a one-to-many relationship between customer and orders. And I can look at the properties for my class, I can change the name of the class that gets generated. I can define where that is, the access. Those delete, insert, and update, those are ways to plug in store procedures. And we will talk about those later on. You can, each single field, you can set all sorts of stuff related to that field. So this is a way for you to help the tool if the tool doesn't infer the right thing from the database, but it usually generates something reasonable. I can do more complex stuff. For example, I want order details, products, and suppliers. So let me drag those, and the tools automatically inferred all the relationship between those guys. And I can also do this. No, do this. Huh? And I don't know why you can get so close as this. This is almost threatening, but all right, this looks more normal. So let's go and look what has been generated. So this added this file to my project. I can then go and look at the code that is behind this file. And let me go and collapse everything to definition. You will see that this code is exactly, well, very similar to the one that I created by hand. I have my Northwind data context that inherits from data context. This is why I did it by hand before, to show you, to kind of, yeah, to show you all the steps. So this is the same as before. It has a bunch of constructors to kind of create the data context in many different ways. And it has one property for each of the tables that I've been dragging and dropping on my designer surface. And each one of those tables became an object there. And the object has the table attributes exactly as before. So in essence, the tool is an easier way to write that code. Okay, you guys with me? Yeah? So now that I have that, I can go and write code, this time using the Northwind data context. Let me add the log here. Let's say in the dot. Now I have all the tables. I can access them with IntelliSense. I can say products, orders. You know, in this case, I want customers. All right, let's select C. And it just works as before. So that's the simplest possible way. If you have a database, you just open up the designer, drag and drop table, run it, and it works. There is nothing else for you to do. See how we are, you know, we're getting closer to what I said at the start, that you want to work with your database in the same way as you work with your objects. And so that's, we are getting there. Now that I have a more complex database, I can do more interesting stuff here. I can say, for example, and c.orders dot count is more than 5. So this query brings another interesting point. You might be wondering, is this query language powerful enough? I mean, it's just a toy language, and whenever I need something real, I need to go down to SQL and write it in SQL. And the answer is no. This query language is as powerful, or it is indeed more powerful than SQL. And I'll try to prove you that in a second. But it is a real language. We asked the SQL team to give us queries that cannot be represented in this language, and there aren't. At least we couldn't find them. And it's relationally complete, so it's a real query language. For example, this query gets translated to nothing. That's the good thing about demos. Oh. All right, so this query gets translated to this, and the only difference is this is the first thing where the city equal London, and then we are selecting the count of how many orders there are, and we are comparing that with P1, where P1 is 5. So again, the translation of the query, if you think about your query, it's getting, the query here is perfectly understandable. There is no issue there. As you go to SQL, the queries start to get more complex because you are navigating relationships. Here you are navigating a one-to-many relationships. So the way to do that in SQL is through joins or through subselect. So in this case, the engine chooses subselect to specify that particular query. But we cannot keep, in this case, the query exactly the same because SQL doesn't have syntax to navigate relationships. And okay, so this is a slightly more complex query. Let's do even more. Let's say c.contact name, and let's say c.city, and orders equals c.orders. So let's first look at the result of this query to make one particular point. So the result is all the customers that have more than 5 orders, the name, the city, and all the orders for that particular customer. You cannot do this in SQL. I mean, the beauty of SQL is that everything is a table. A table is a table is a table. And that's good. I mean, that's the simplicity of SQL. In SQL, your query over these tables, and what you get back is a rectangular structure. And that's the way that SQL works, right? You cannot get back this kind of hierarchical structure because that's not one of the concepts of the relational model. It doesn't have that. In our case, we are querying over an object model, which means the object model is a graph. So the result of the query can be a graph. You understand what I mean? So in this regard, at least, just because the domain we are querying over is more complex, if you wish, or richer, then the result can be richer. Okay, in SQL, this query, the only thing that you can do with this query is you have to take the orders and splash them down to some kind of aggregate. For example, sum or something like that, because then the result is rectangular, and that's something that SQL can return. Okay? That's not to be, it's not a problem with SQL, it's just the way SQL is, it's its strength, if you wish. So let's look at the query for this thing. Now the query, it becomes slightly more interesting. So this is exactly as before. It's the same exact where clause as before. Notice that the engine needs a left outer join to achieve this because it's joining customer and it needs all the orders for those customers. So it does that with a left outer join, and that's kind of understandable. The thing that might not be that understandable is why it's selecting the count for the orders. And the reason for that is that imagine the table that SQL returns. It has the customers, it has one customer, and all the orders for that customer. So the engine needs to know how many orders are there so that it can fill one customer and start with the next one. Okay, that's the reason why it's selecting the count for how many orders in that customer are there. I know that this is, you guys understood what I just said, or it's completely esoteric and just, I'm just happy to say, no, there is, okay. So, but that's the reason why there is that count there, because the engine needs to know where a customer stops and when the other one starts. I think, I know it might be strange to look at all this SQL, you know, in 1 hour you see like a lot of, but that's the way to understand this kind of stuff. I mean, you really understand the guts of the framework by doing that. So as you see, our little, we call it beautifier, our little thing in the pipeline at the end of the query is trying to do the best that it can to still present you something understandable. These kind of query are the classical one that if you don't have such a thing, they become huge, and you have no idea what your framework is doing under the cover. This time around, still understandable. But I can do even more. I can come here and say, you know, I don't want all the orders, but just give me the orders that has ship via, which I don't know what that is, but it doesn't matter. And I want to select, for example, just the order ID and the ship via, like so. Is it, you guys think that this query is still understandable? Yes or no? Move your head in one of the two directions. Okay. The SQL query, not so much. Yeah, it's getting bigger, but you know, and that's kind of, that's another point worth making, right? That when you work at your business logic layer and you have relationships between objects, expressing the query in terms of your object model, it's relatively simple, but the translation to SQL then, it becomes more complex because SQL doesn't have those concepts of navigating relationships. The only difference really between this query and the previous one is that now I'm testing for the ship via of the orders because I want to return just the ones that have ship via equal to. And now the select is more restricted because I said that I don't want all the data in the orders, but just those 3 fields. Okay? The count is still there because we still need to know when one customer ends and the other one starts. Okay? Now that's a beautiful query, isn't it? Right there. All right. Let's talk about something else here. So let's look, you guys can read this or it's too small? Too small, huh? Let's make it slightly bigger. Okay. Notice I have a customer here and I have a supplier. Those two guys, there is no relationship between them. There is no little line tying them, which means the creator of this object model didn't think that it was interesting to create a relationship between customer and suppliers. But still, I may want to query across those two. I may want to ask questions like, what are all the suppliers that live in the same city as a customer, for example, right? This is a fair question to ask. But in the object model, there is not that relationship. And this is the case where in SQL you would use joins. You would join on the city table, right? On the city field. And you can do exactly the same in this query language. Wherever the creator of the object model hasn't put a relationship between two things, you can still use joins to query over them. So joins make sense even in an object model. It's not true that in an object model, joins, they are not useful. They are indeed useful. And they work like this. You say join S in db.suppliers on sc.city equals s.city. city into subs, where, let's say, subs.count is more than 0, so just the one that have one of those guys. Select new c.contact name, c.city, and let's pick subs, like so. Let's run it. Well, let's first explain what it does. So this is a join. It's quite similar to the SQL syntax. You probably understand what it's doing. The thing that might be kind of puzzling to you is why we say equals there and not equal with the C# syntax. And the reason for that is that if we allow you to say equal, then you would think that you can say more than equal as well, or less than equal, and you cannot do that. So that's why instead we use equals to convey the message that that's the only thing you can use at that point in the join. And the rest is fairly explanatory. A different way to think about joins, that's a way that I particularly like, is so the creator of the object model hasn't built a relationship between customer and supplier, so joins are a way to build that relationship on the fly. And that relationship is called subs. Right, it's like your customer objects on the fly inside the query gets a supplier's relationship. And then it can navigate it like it's doing here. Okay? And the interesting thing about that worldview is that when you go and execute the query, you will see that the query is incredibly similar, almost identical to the query that we used to navigate relationships defining the object model, because we are really doing the same thing. We are just adding a new relationship that wasn't there before. And you will see there is still the left outer join here, exactly as it was there before. We still select the count exactly as before. And this is the where clause for the suppliers. Okay, so it's exactly the same as having a relationship, just that you are creating that relationship on the fly. You guys with me? That okay? Move your head in one of the standard international directions. You're gonna get hurt if you continue doing that. All right. Yeah. So this is how these are joined. So to kind of summarize where we are, we show you starting from a very simple query, just db.customer. We made the query more complex. We created a new object model using the designer, and we went through and we talked about subqueries with the orders that query right there, and we talked about joins and why joins are useful even in an object relational layer. And I'm not pointing this out, but everything is strongly typed here. I mean, if you write something wrong, you are going to get a compile time error, right? It's you can set breakpoints, you can do all the things that you were used to do in your object, but that you cannot do if you are using SQL and strings to query. I'm not bringing up any of those points, but I'm making them. I hope you guys kind of, yeah, I think you get that. All right, so now I know how to bring objects in memory. Now I have all my objects in memory. How do I modify them? How do I change my database? So let's take a look at that. Let's remove this query here. And instead, let's do this. So I'm retrieving one customer here. I'm querying for the customer with customer ID equal this string. And so I'm getting the first one. So now I have one customer in memory. Now Now, this is how you add one order to one customer. You just create a new order, set the ship country, and add the orders add the order to the orders collection. Notice that there is nothing strange in this code. You are just doing exactly the same things that you would be doing if you were just working with your object model. Nothing is different here. You're just working with your objects. So this is how you insert a new order. If you want to modify an order, you do this. For example, you for each over all the orders in the orders property, you pick the one with freight more than 100, and you just subtract 10 from that one. Again, nothing specific to link to SQL in this code. It's just the same exact way you would have done that in your own code. So all of this piece, it's all exactly the same. The only difference is that if you want to propagate the changes to your object model to your database, then you need to do this. You need to call that method at the end. Okay? So in essence, you retrieve all your objects, you modify them in whatever way you want to. You add new order, you change names, you do whatever you would do, whatever your business logic calls for. When you're all done, you call submit changes. And the framework takes care of generating all the insert, updates, deletes, everything that is needed to translate your changes to your database. And this is what gets generated. All right, so we're going to go through all of this, but fast. So here I'm selecting my single customer. See that P0 is a route. Okay, so I'm selecting my single customer. Here I'm iterating over all the orders for that customer. See that, again, the customer ID is this one. Now I found my order that is more than 100. It's so high because I've given this demo so many times that, yeah, anyway. So it's more than that. So now I call submit changes. So the code from there on is the code that submit changes generates. So let's take a look at how it works. It says, okay, update the order by setting the freight to P14. And if you look at P14, it's 10 less than what was originally here. Okay? The thing that might be surprising is all those other parameters to the query. What are those? Those are the original values. So those are the values that were originally retrieved from the database. And the query is using those original values in the where clause here. See? The reason why it is doing that is for optimistic concurrency. So optimistic concurrency says that when you update a row in the database, you want to update that row just if the data that is currently in the row is the same that you originally retrieved. Because if it is not the same, that means that someone else changed the row from the time that you retrieve it, from the time when you're trying to update it. And if you update in that case where someone else changed the row, you might end up doing some terrible things, like removing all the money from an account or doing these kind of things. But if you use optimistic concurrency, as we are doing there, in that case, then the updates succeed just if the data that was originally retrieved by the framework is the same data that is currently in that row. Okay? So optimistic concurrency is the default that we use internally to submit updates. That works well unless when it doesn't, which is when you need pessimistic concurrency. So there are cases where you really want to take a lock on that row. And you can easily do that by just starting a transaction in the code. I will show you maybe how to do it, but you just, essentially, you put your code inside new transaction scope and transaction scope.commit. And then everything will be inside the transaction. So you can have both models. By default, the one that you get is optimistic concurrency, because it's the one that works the fastest in most scenarios. So that's how we update stuff, and this is why you see all those parameters here. Now we insert. So this is the insert statement. Those are all the values for the parameters we are inserting. What is interesting is this select statement. So you wouldn't expect to have a select statement there. The reason why it's there is that order ID up there is a auto-generated column. So we need to retrieve the value of that column generated in the database to push that value in the object layer. That's why there is a select statement as well on top of the insert statement to retrieve that value. This code, this particular SQL is different in the recent builds. We found a better way to do it, but the concept is still the same. We need to propagate that value up to the object layer. And that brings a good point that I forgot to mention. I'm showing you all this code not so that you can rely on it. I mean, don't write tools that depend on the shape of this SQL, because we will change it, right? I mean, it's not like I'm just showing you the SQL as a way to understand how the engine works, okay? But we reserve the rights to change. If we find better ways to generate this SQL, we will change it, right? For example, if SQL Server adds a better operator to do a particular thing, we will use it. So yeah, don't take a dependency on this SQL. All right, so this is how you insert stuff. The guy's tired? Is it boring enough? Or I can make it more boring. All right, let's think about something else now, store procedures. So I know that's something that's dear to your heart. If you don't have access to your database administrator doesn't give you access to your database, but it just gives you store procedure to modify your data. Can you plug those in the framework? And the answer is yes, you can do that. The way to do it is by, again, dragging and dropping a store procedure, for example, update order on the right surface there. So now I have update order. I can go to the order object and say configure behavior. And now I can change how this order does insert, updates, or deletes. For example, I want to change updates. The default is to use the runtime, which is the runtime is going to generate the update for you. But if you have a store procedure, you can say customize. You can choose your store procedure. Then you have to associate the value of the properties in the objects to the parameters to the store procedure. So for example, you want to say that the customer ID parameter to the store procedure correspond to the customer ID, to the customer ID property in your object. My build is broken, so usually it does that automatically, but if the name is the same, but yeah, this one doesn't. So I assign those three values and the order ID. Notice that there is both a current and an original there. The reason for that is that you might want to write a store procedure that uses the original value. And so in that case, we give you a way to pass that value in. If you want to do, for example, optimistic concurrency yourself inside your store procedure. So, okay, so now I have associated, I have done the right thing. So now, do I need to change my code to make any of that happen? And I see a guy in the audience doing this, and he's correct. You don't need, it's like a game. You don't need to change any of your code, but when you run it, now the update is done through a store procedure, right? So, yeah, so in essence, you are programmers, the guys using your framework, they don't even have to care if they're using store procedure or not. They just modify their objects in whatever way they want to, and then they call submit changes, and the right thing happens for them. Okay? What about using store procedure for retrieving objects, not updating them? So let's do that. So the way to do that is by oh no, wrong one, sorry. By going here and dragging and dropping store procedure. For example, I have a customers by city store procedure. So I drag it over there on my right pane. I go to my program, and then I can start using that store procedure. I can say var query equal db dot, and it's called customers by city. So now see that in my IntelliSense there is a customer by city function. And I can drag and drop all my store procedure there, and they all appear as a function in my class. So I want to execute this one, say London, like so. And I want to print out the result. And if I go and run this, you will see that now I am executing the store procedure right there, and see that we are still using parameters here to pass there. And from the point of view of your programmer, that this is as simple as calling a method on your object, okay? But there is a problem with this, though. The problem is that if I want to sub-filter my store procedure, for example, I want to do this, where c dot contact name starts with A, select C. So if I want to execute this one, so the store procedure is still executed, but there is no filtering going on in the database, right? I'm retrieving all the results of my store procedure, and then I'm filtering in memory. And that's, most of the time, that's not efficient. That's not an efficient way to do things. You really would like that even if you are using a store procedure, you still can filter this thing in the database, okay? So there is a way to do that in SQL Server, that is by using table value functions. So let's use those. I have a TVF customers by city that I drag and drop on my right pane. So now if I go back here and I change a customer by city to calling the table value function instead, now if I run the code, you will see that now the filtering is done in the database, okay? So if you can, and most often in the case of this kind of object relational framework, you can do that. Table value function are kind of a more efficient way to do things, because the query gets evaluated by the query engine instead of being evaluated in memory, okay? All right, so let's talk about transaction for a second. I briefly touched the subject before. So what if you want to execute this inside a transaction? So first of all, if you are using distributed transactions, then you don't need to do anything. the framework will look for the presence of a distributed transaction, and if a distributed transaction is there, it will enlist in the distributed transaction. So I'm saying like we built that, but we don't do anything to make it happen. It's just that when you start a new connection, it does that by default. So we just get that behavior. But it turns out that that's what you really want. If you're using distributed transaction. If you want to start your own transaction, then there are two ways to do so. One is by surrounding your code where is it? Surround with, oh, here it is. With the transaction scope. So you just start your transaction scope at the start of your code, and you just close it. Here, that's the way in .NET to use transactions, and that works well. And the other way to use transaction is if you have a transaction that is already running, maybe you were writing some SQL code up there, and you want to use the same exact transaction, you can go here and say db.transaction and assign your own transaction to continue for the framework to use, if you wish. So those are all the ways that you can. I cannot think of any other way of doing it, but we support all the ones that I know about, at least. All right, so this is about transaction. Now, oh no, this one. All right, so this is the usual summary. I hope you guys, did I succeed? Did I convince you that working with relational data is as easy as working with objects? Yes? No? Almost? Yeah. Yeah, you have to try it for yourself, really. I mean, you have to go and try to write a little app using this stuff, and it is exciting. We have people in our team. My team is the C# team, right? So we have plenty of people that never use databases. They're just language guys. They don't care, right? And they never use them. And we did an app week with this stuff. So the app week are where in our team everyone gets to use the product and write code for a week. And all those language guys, they all use this, and they all came back saying, wow, it's very simple. You guys did a wonderful job. So that kind of was a bit of a proof to us that we made working against the database as simple as maybe there are also simpler ways, but at least relatively simple. So that's what I want you to get back from this. And the other thing is store procedures. We have deep support for store procedure. I know that many of you can just use store procedure. They cannot use dynamically generated SQL. So we really thought deep about that scenario. And you can use store procedure for all sorts of things, to update your objects, the only way we haven't found a way for you to write a normal query, a query that is just a query with a where clause, a select clause, and all those things, and have that to be translated to a store procedure. That one, we haven't found a way. But all the rest, calling a store procedure to retrieve objects, updating, so all the rest, we plugged it in. So yeah, so we've got deep support for that one. All right, so that's all I have. Thank you very much, guys. And I open it up for speak. There are microphones up there, so please go over there, and so that your question can be recorded for the posterity to hear.
Hello, I have a question. You did a left join, and then in the where clause, the count bigger than 0. But is it possible to do just an inner join? Because that's the same.
Yes. I mean, yeah. It is possible. What I did was indeed an inner join, right? It gets translated to a left outer join, but in terms of the object model, it was an inner join.
But for SQL Server, it's not the same.
Yeah. For SQL Server, it's a left outer join. Yeah.
Yeah.
But yeah, you can do that.
And how? Or
Oh,
that's
just by. That's a good question, right there. just by just by writing it, the way that it's written. You just do join and you do the equal, and that becomes an inner join.
Okay, thank you.
Yeah. Yep. There is also another microphone there. Oh, sir. Yep.
I have a question regarding timestamps.
Yes.
Are you able to use them for optimistic currency?
Yes. If there is a timestamp, you can tell the framework to use that one for optimistic concurrence.
You can tell it?
Yeah, it works.
Okay.
I don't remember if we do it automatically or you have to explicitly in the attribute says use this one. That I don't recall, but you can use it. One of those two ways.
Right now you are supporting SQL Server 2000 and 2005. Is that correct?
Yes, I forgot to mention this, and this is very important. So thank you for your question. We support all the flavors of SQL Server. We do not support in this release, the one that ships with Orcas, we don't support any other database. If you need to work with another database, there is another framework coming, and it's called Link to Entities, and it's going to ship in the first half of 2008. And these guys are working with external partners to make the framework work with multiple databases. Yes. So that's the state at the moment.
Yes, I'm also concerned about SQL Server 2008. What is?
Oh, that works. We support
works,
that.
Yes, but are you optimizing for SQL Server 2008 features currently?
Yes, we are. Indeed, we are using cross-apply, for example. That is SQL. So the problem that we have is the opposite, which is our code is optimized for SQL 2008. But when we go and we support SQL 2005, for example, then we need to de-optimize it. And to go, and for example, there is no cross-apply, so we need to simulate cross-apply inside the query. So, yeah.
Thank you.
Okay, thank you.
Okay, you showed us a simple way to generate the objects classes by dragging and dropping tables.
Yeah.
But what is the support for an update? Say that if DBA changed the field name or something, do you have to regenerate everything, or is there any support provided?
Wonderful question. Yeah. So again, it's hard to say everything, so I forgot about that one as well. So there is no automatic notification from changes in the database to your design. So you don't get notified if something changes in your database. So if you run it, it fades. What you can do is you can go and regenerate the design, kind of the object model. And by doing so, you won't be breaking any of your business logic. The reason for that is that we generate all the classes as partial classes so that you don't write your business logic inside the generated code, but you just create partial classes that just contain your business logic. So every time you regenerate the code, you are not overriding your business logic. That answer your question?
Yes, it did.
Thank you.
Thanks for a great demo. But I think that the examples are a little bit simple in the way that you are mapping one class to one table. What would be the strategy if one class maps to several tables?
Yeah, it doesn't work.
Okay.
That's a strategy.
Great answer, thank you.
So yeah, so link to SQL, that's kind of an harsh way to pose it, but link to SQL for us, our design philosophy is to build the simplest possible thing to access a database. So all those more advanced scenarios, they will be supported by link to entities. That is the one that will be shipping in the first half of 2008. Link to SQL is the super, super easy, super fast, one table to one object kind of mapping. You can play tricks and fake a bunch of things and work around a bunch of limitations. But I would be lying if I say that we support that scenario. Okay. We do not. Yep.
With existing stored procedure calls, it's quite easy to mock them and stub them for unit testing purposes. Is there any thought into how we can unit test things using Link?
Well, yeah. I don't. What is the issue that you see by writing normal unit tests against this one?
If you're unit testing the code and you don't have the database for the tests, then normally you could stub out the...
Yeah, then it's your own. I mean, then the best thing you can do is create mock objects that look like the database and returns you the result, and then you go and code it. But we haven't created those. You will have to create them yourself.
Okay.
Yeah, sorry. Yeah.
I have two questions. First one, does this stuff work when assembly is hosted in SQL Server, so in SQL CLR? And the second one, you showed us a very simple join, an equity join that uses equals. What do I do if I have a join using more complex things like between or case inside the join expression?
Yeah. On the first one, it works in SQL, in assemblies inside SQL Server. I do not remember. I have to get back to you on that one. I don't recall it if it does. On the other one, yeah, it depends on the join. For sure, inside that join clause, the only thing you can have is equals between two simple things. There are ways to kind of change the query in such a way to achieve similar results, and that's what we did in some of those cases, but it's not that simple. So yeah.
Thank you.
Thank you. Yeah.
Hello. I have another two questions. First, you show us how to retrieve identity after insert. My question is how to retrieve other generated data during insert or during update, because it happens.
Yeah, so the way to do that is by using an attribute on the field of the objects that is called, I don't remember how it's called, but there is an attribute that you put on the field and say, update from the database. And so whatever you do, it gets the value and push it on the object.
And another is bigger one, I think, because you show us how to retrieve data, change, save, and what about disconnected data? When I retrieve data, I lose my context, I do something with it, and I try to get it back, put it back to...
So the objects that you retrieve with a link to SQL can be sent to a different tier, can be modified in that tier, sent back, attached to a data context and updated to the database. So that scenario works. What doesn't work in this release is sending the old values back so that you can do optimistic concurrency. So if you need optimistic concurrency, the only way to achieve that is or you send them back yourself and then you push them in, or you use timestamps, because timestamps, they just flow naturally. But we haven't built an automatic way to do that.
Okay, thanks.
No problem. Thank you.
Hello.
Hi.
My question is, if I have my custom base type, like my integer, my decimal, that are also nullable type, and I made by hand my object classes.
Yep.
This can work.
No.
No. Also,
I was thinking while you were asking the question, I was thinking of how we. I mean, there are ways to make it work. You can. Yeah, I need to write a blog post about that one. You need to, because I get that question a lot. What you need to do is you need to intercept the expression tree that is generated, look for your object, substitute that part of the tree with a tree, with an expression that goes against your underlying table, and then you give it to link to SQL. And it gives you back stuff. So it can be built, but on top of what we have, but it's not that simple.
Because I think that if my type are convertible and
No,
I use attributes.
We don't look that. There is also a simple. So, okay, the simplest possible way is you just write the fields that are inside your type in the containing class, and then you add a property to the containing class that creates your type by loading those fields.
Okay.
So that is very simple to do, but then you cannot query over your type. You can query just over the underlying fields. To query over your type, if you need a query over your type, then you need to do what I described before. That's the full answer, I think.
Okay, thank you.
Thank you.
Hi. Your demonstration of the select stored procedure didn't return a customer object, but something else, result, whatever it was. How can I make change to this object and write it back to the database?
Yes, so when we retrieve objects, if you retrieve them with store procs, they go inside our caching for the original values and everything. So you can indeed send them back to the database. If they are, I mean, if you have a store procedure that return a real entity, so if you have a store procedure that return a customer, and you have defined the mapping between that customer and tables, then, or you have defined store procedures to do the mapping, then that whole thing works.
But can I attach a select store procedure to a business object?
So if you are...
Let's say I know my store procedure returns customers. I need a way to...
Oh yeah, you can, of course. Sorry, I misunderstood you. In the tool, you select the store procedure, right-click, properties, and you say the return value for this store procedure is customer.
Okay.
I haven't showed it, I forgot.
Okay.
But yeah,
thanks.
that's how you do it.
Okay.
My question is
I don't know how much time we have, but I don't know. I continue until they stop me. So.
Okay, thank you.
Yeah.
My question is also about querying data using store procedures. How can IntelliSense work in such a case, and how can the language still be strongly typed?
Yes, so the IntelliSense knows the result of your store procedure. So if you write a store procedure, then the return of that store procedure is indeed strongly typed. And the store procedure itself, when you drag and drop it to the right pane, creates a strongly typed method. So both the method and the return are strongly typed.
So the store procedure is parsed or is it executed?
Is what?
Is it parsed when you drop it, when you drag and drop it?
Yes.
Okay.
Yeah.
Thank you.
Hi.
Hello.
I have a question there concerning possibility of using of cursors. Do you have anything in the framework to force it to use cursors to stream data?
What we used is the underlying data reader to retrieve data. So that's what we use. So the ADO.NET data reader, if I recall correctly, use a cursor model. What's the thing? Fire or something like that. Cursor model. So it's the fastest way to get data out of the database. There is no way to set a different cursor, like a server-side cursor. We do not support that.
Okay. And second question is concerning what you told you could use some properties in the designer to tweak the way it would generate some things. I put you yesterday a question concerning representation on other kind of relationships, like instead of aggregation, inheritance relationship. You told me you could put some attributes or properties there.
So
my concern is, if you regenerate, you lose those properties. If you just have to refresh,
yeah, you're right. Yeah,
you lose the
them.
settings.
You do lose them. That is a problem.
Yeah, thank you.
Yeah, good point.
Hello.
Hello.
My question is, what if you want to return your objects from a service? In a sense, for example, you want to create Windows Communication Foundation service and return your generated classes objects from this service. What would you recommend? To create a separate DTO objects and then map those link objects to that and then return it? Or can you return just a link to SQL objects from the service?
So there is a lot of discussions out there of what's the right way to do that. You know, there are people that think that you have to return the data set all the time and then create objects from the data set. There are people who think that you have to return strongly typed objects. I tell you what we support. Yeah. What we support is returning objects and streaming those objects to a different tier. So that is supported. You can create a CF service that does that.
So you put data contract attributes on top of your object?
Yes. Indeed, in the designer, there is a flag that you set that will put data contracts on each one of your fields.
Okay.
So that is fully supported and does work.
Okay, thanks. One quick question. Could you, in a few points, 1 to 3, convince us that we need to use link to SQL and not link to entity? Because I guess link to entity is quite soon, and it supports multiple databases, and the interface to outside is quite the same as a link interface. So why do we need to use link to SQL then?
Well, as I said, link to SQL is the simplest possible way to go and use your database. And when you support simple stuff, your engine can be very much simpler. And so you can expect, advantages with that.
Okay, thanks.
No problem.
A very simple question.
Yep.
Can you work with views? And will that be similar to working with tables?
It's exactly the same.
Thank you.
No problem.
Hello. Hello. I have two questions.
Hello.
Question one. How about union statements? Is there a native way that I can do this in LINQ, or do I have to use a stored procedure?
You said union?
Yes.
Well. I do not remember if in our engine we built support for union, which means what I mean by that is that when you have a query that has a union, I don't remember if we're able to translate that to SQL or if we execute the union in memory. I believe we translate it. If I had to bet, I will bet that we support that case, but I'm not 100% sure. We can try it in 5 seconds, but I do not remember.
Well, I'm very interested. Second question is, how about nested transactions? Is that supported?
How about what?
Nested transactions.
Yes, all the same transactions of video.NET are supported.
Okay,
so, yeah.
Thanks.
No problem.
Hello. I would like to know if you support reject changes scenario and bidirectional data bindings.
Oh, what was the first one? I'm sorry.
Reject changes, like in datasets.
Oh, you mean
to cancel all the changes we made to the object
to the
and
objects
to return to the
to revert
original
them back?
values?
No, we don't support that. The second one was? Sorry.
Bidirectional data binding.
Yes, we do support bidirectional data binding fully. You can bind your objects, you can modify them, delete them, whatever, and then you can submit them to the database.
That means your designer will implement the interface.
For further rejection.
No, notify property change, for example. Is it implemented by the designer?
Yes.
Yes. Okay.
We implement all the interfaces that are necessary for data binding.
Okay, thank you.
Yeah, thank you.
Hello, just two quick questions, please. You showed us how to create objects from the database by using design time. Is it possible to do that in runtime?
Well, so let me take an aside. We have a command line utility that you can call and generates the objects as well. So in theory, you could run that and generate your objects at runtime. Now, I'm not exactly sure of why you would be doing that though. Because when you generate that at runtime, that means that all the code that you have that is using those objects cannot be written because those objects don't exist yet.
Yes.
So, not exactly sure.
We have a similar concept using one-to-one classes. So my question is whether I'll be able to use them with...
Are you talking about something like Ruby on Rails?
No,
so
no,
that it's dynamic? No, okay. Sorry.
Okay. Second question, you showed us the output from the SQL, and there were correlated subqueries. My question is, why weren't the having clause showed over there?
Well, that's just the way that we choose to generate the SQL. The guy that works on the query pipeline has been working on the SQL team for more than 10 years. So he knows how to optimize that thing. So I don't know the exact reason for that choice, that particular choice, but I trust him that it's the right one.
Okay, thank you very much.
No problem.
Simple question. When using Link, and now this integration with databases becomes so easy, do I still need store procedures?
I'll take the last one, then we have to close and you guys have to come here. Sorry, can you repeat?
Yeah. Do I still need to write store procedures since integration with Link now becomes so simple?
If you need to write store procedure, that's your question?
Yeah. You mentioned
so
the scenario.
I have my own philosophy, but that's by no way, the standard or anything. What I do is I write the application in the most maintainable way that I can, which in my case means no store procedures. Then if I have some hotspots, I attack a profiler to it, and if I have some points that I discover need to be optimized for performance, in those points, I might use a store procedure. But if not, I don't. So that's how I do it. But,
big discussion.
I'm sure you can talk with plenty of people will tell you different things.
Thank you.
All right, thank you. You guys can come here.